between 0 to 2 pi, you take this graph, you copy paste this, you are going to get the same graph over and over. Correct? You're going to take this graph from this place till this place. You can see the graph. This was your graph, right? If you cut this portion of the graph and keep copy pasting it, you'll keep getting the same graph, isn't it?
Yes, sir.
So the period of both sin x graph and cos x graph is 2 pi. Okay. So I'm talking about periods here. It's a very interesting concept on which they make mains and advanced question. So have you heard of fractional part?
Yes, sir. Yes, sir.
Yes. That. So fractional part keeps returning you the decimal portion, right? Like if I say fractional part of 1.5, that means the answer will be 0.5. So for that, there is a definition, a real definition for every real x. It is distributed into GIF of x plus fractional part of x. GIF of x gives you the nearest integer it has crossed when you move from left to right, and fractional part is the decimal. So you have to be little cautious when you work with positive values and negative values. Take a positive value like 2.14. So GIF of 2.14 plus fractional part of 2.14. So what will be fractional part of 2.14? It will be 0.14, isn't it?
0.1.
GIF of 2.14 means it's 2. Because
2.
from left to right, when you move on the number line, the recent integer you would have crossed is 2. So 2 plus 0.14 is 2.14. Okay. So I'm asking you to be little cautious with the negative values. Because the negative values, you'll have to give it little differently. So suppose I'm taking minus 2.14. Can someone say what is GIF of minus 2.14?
3.
It is minus 3. Because when you move on your number line, minus 2.14 will be here. What is the recent integer you have crossed when you moved from left side to the right side to come to that number? Sorry, there's a hello. Are you able to hear me?
Yes, sir.
Yes, sir.
Yes, so I was asking you about what is GIF of minus 2.14, and I showed you graphically it's like the recent negative integer that you would have crossed being minus 3. So what will be fractional part of minus 2.14 then? Because this equation has to be satisfied, no, for every real x. It is equal to GIF of x plus fractional part of x. Can someone say that correctly? Can someone say that correctly?
Minus 3.
Yeah, minus 3 is for GIF of minus 2.14 accepted. I'm asking about fractional part of minus 2.14.
0.86.
Absolutely, it's 0.86.
1.1.
Minus 3 plus 0.86 is only minus 2.14, right?
Oh, yes, sir.
So you have to remember that fractional part will always give you values only from
Yes,
0
sir.
to less than 1. Fractional part of a real number will always give you values only from 0 to less than 1. Don't forget this. So I want you to try yourselves drawing graph or fractional part of x. I want you to try drawing graph for fractional part of x. Everyone, you can give a try yourselves. You can try drawing graph for fractional part of x. Danya, you can try. Aishi, Jeevish, Vidyatram.
Yes. On your screen. So by annotating or in our notebooks, I don't.
You can try in your notebook and then you can show me if you have got it. Just show that notebook on the screen.
So does it go like this?
Yes, Kiranmai, you're right. Who else has got it?
Sir, got it, sir.
Got it, you can show me. Hiranmai showed me. Aishi, did you get it?
Sir, it's coming blurred in the screen, sir.
Take it little back so they can see. Yeah, it's right, Aishi. I saw that.
Sir, is this right?
Samyukta, yes, absolutely, it's right.
Thank you, sir.
Okay, so then almost all of you have got it. Danya, you didn't get it? Danya, Jeevish, Sudhitra.
Yes, I got it.
So it's getting blurred out 1 minute.
Okay, so yes, it seems like you're almost getting there. So now you can say the period for that. Yeah, Danya is showing on screen. Oh, yes, yes, Danya, it's right. Okay, people, can you say the period of this function
So
then?
is the
Jitram, you're
one?
showing? Absolutely, people, it's 1. So this graphing tool does not understand flow directly it. I'll have to code it like this. So did you understand how I got this? Yeah,
Yes, sir.
very interesting, right? And you have to understand how graphs are being drawn as well. So I can keep manipulating my graphs of sin x, cos x and all, but period. What is happening to the period? If I multiply my function by a scalar, will it affect my period? If I'm going to multiply my sin x graph, this is my sin x graph. I know sin x will give you values from -1 to +1. If you are going to multiply sin x graph by 2 times, what will be the range of 2 sin x?
Minus 2
Yes.
plus.
-2 to +2 because you multiplied by 2. But will it affect the period is my question.
No, sir.
It won't affect the period. You can see that happening. Only thing is the graph will be lifted upward till it reaches 2 at the same point where it was reaching 1. And it will be pulled downward to -2 at the same point where it was reaching -1. You can see that. You know, your sine reaches 1 at 90 degrees. At the same point, now it's reaching 2. And you know, it at 270 degrees, it will be reaching -1. At the same point, it's now reaching -2. So then you can clearly say it's not affecting my period, isn't it? Is it affecting my period?
No, sir.
No, sir.
Beautiful. But if you are going to, this was original sin x, but 2 sin x you can see. Then if I show 3 sin x also, you can see what's happening. So this is the lunar movement. How your waves, the tidal waves keep increasing its height. Very close to that full moon day and like when it's like no moon day. You understand how science works with respect to our graphs? So there will be a system of people, team of people working on this, trying to find out what's happening. Like if they finds any aberrations, meaning like how your tidal waves keep increasing its height close to the full moon day and how it keeps decreasing in height with respect to the no moon day. But if I affect the angle, what should happen? If I affect the angle of sin x, what should happen? So meaning like instead of sin x, if I want to draw a graph sin 2x, what do you think will happen?
Period will be halved.
So why is period becoming half?
Because we learned this in physics, but the value of k is changing, and lambda is the period, which is the wavelength, and we learned that lambda is 2 pi by k. So
Good. So the idea is, you told me when it was reaching 1. When it was reaching 1 at 90 degrees. Now it will reach 1 at 2 times half of that, right? 90 degrees. So if x is 90 degrees, when 2x has to be 90 degrees, then x has to be only 45 degrees, no?
Yes, sir.
So it's reaching its maximum half of its way. Same way it will reach its minimum half of its way. So that means the period is getting half. So we can generalize it saying, if sin x period is 2 pi, if period of sin x is 2 pi, then period of sin ax will be 2 pi divided by that multiplier. So your graph will keep getting flattened out. Your graph will keep getting flattened out. You can see that if I write sin 2x, what's happening to the graph? Now like I was able to reach the maximum very much prior. So here if I say 2x, meaning value of a is 2. So 2 pi divided by 2 will become pi. Now you can see the period is now just pi. 0 to pi, you see the graph, that is only getting copy pasted. Understood, right? So, but on the contrary, if I'm doing sin x by 2, what will happen?
it will be doubled.
Yes, period will get double. The graph will basically be flattened out, meaning the curvature is getting reduced.
I think your sin x has been divided by 2, and it's not sin of x by 2.
Sorry. Here it is, I wanted to write sin x by 2 and it understood it wrongly. So you can see what's happening at sin of x by 2. What is happening, people? Can you see that?
Yes, sir.
Now the period has become doubled because you have the multiplier here was 1 by 2 times. If you divide 2 pi by 1 by 2, what will happen? It becomes 4 pi, isn't it? You can see 0 to 4 pi, the stretch out happening, correct? So more and more I'm going to divide this angle, then what will happen to my sine graph? It will almost look like a flat line.
Yes, sir.
Yes, sir.
If I do sine of x by 20, see what's happening. It almost looks like a flat line. And what is happening to my period if I'm going to multiply by 1 by 20, meaning 2 pi divided by 1 by 20 will become 40 pi. The period will then become 40 pi. Can you see that? So why am I pushing more focus on graphs? Equations which cannot be solved algebraically, if you take help of graphs, it will become more simpler. Now question comes, Jivish, like how will I make a question on this? You see this. Find the number of solutions of sine x is equal to sine of x by 20, where x belongs to 0 to 40 pi. Now you can clearly notice the intersection points is going to be the number of solutions. They don't want you to say the solutions. They only want you to comment about the number of solutions.
So it's 2.
Of course not, Jivish. So number of solutions, number of intersections, man. So you understood the sine of x by 20 as a period of 40 pi, because it will be 2 pi divided by the multiplier of 1 by 20. It became 40 pi as the period. That means until it reaches 20 pi, this sine of x by 20 graph will be above.
Yes, sir.
So you can clearly see the intersections then. Can you see the intersections, people? At 0, they're both intersecting. At here again, 2 points. Every half cycles will keep creating 2 intersections. On the top, how many half cycles are being there? They will keep creating 2 intersections, except at the point where it attaining its maximum. Are you able to understand, people, what's happening?
Yes, sir.
So between 0 to 40 pi, think about your sin x graph. You just think about your sin x graph at first. This is 0 to pi, then pi to 2 pi. This blue graph, I'm asking you to think about the blue graph. How many half cycles will be above the x-axis? How many half cycles will be below the x-axis?
There will be 20 above.
Yes, there will be 20 half cycles above, 20 half cycles below, isn't it?
Yes, sir.
Now I'm asking you to break this cycle of 40 pi from 0 to 20 pi first, and then 20 pi to 40 pi next. Why? Because in 0 to 20 pi, your sine of x by 20 graph will be above the x-axis. Will be above your x-axis. And from 20 pi to 40 pi, your sine of x by 20 graph will be below your x-axis. Okay. And for all your half cycles above your x-axis, it is creating 2 intersection points.
Yes, sir.
You can see that clearly. Yeah. This is your 20 pi. You can see that until 0 to 20 pi, your sine of x by 20 graph was above the x-axis. And for all your half cycles above that, as I asked you how many half cycles will be above, you clearly mentioned between 0 to 20 pi, how many half cycles of sine will be above? There will be 20 half cycles above, 20 half cycles below. That's what you said, right? If you're a little confused about it, you
Yes,
can just, meaning take smaller gap. So instead of 0 to 20 pi, you just see about 0 to 2 pi. So between 0 to 2 pi, if you take, do you understand that there was one half cycle above, one half cycle below? And if you take 0 to 4 pi, there are 2 half cycles above, 2 half cycles below. Understood or not? If you take 0
Yes,
to
sir.
6 pi, 3 half cycles above, 3 half cycles below.
Yes, sir.
So now my question is 0 to 20 pi, how many half cycles will be above?
20.
Now,
10.
it's half, no?
10
0
above,
to
10
2
below.
pi if you take 0 to 2 pi sin x graph, one half cycle above, one half cycle below, correct? So if you take 0 to 4 pi, you're finding 2 half cycles above and 2 half cycles below. So 0 to 6 pi, you are noticing 3 half cycles above and 3 half cycles below. It's just half of this number, right? So now my question is 0 to 20 pi. So 0 to 20 pi, there will be 10 half cycles above and 10 half cycles below, no?
Yes, sir.
And as you can see, every half cycle above is creating 2 intersection points. So all those 10 above will create 2 intersection points. It will be 10 into 2, 20. So 20 solutions are there above. Correct. And can I say symmetrically say 20 intersections will be below as well?
Yes, sir.
Understood, right, people?
Yes, sir.
That's the power of our graphs. So graphs will help us solve these questions in a much quicker time. But can anyone comment about how can I do this algebraically or using my trigonometric identities? How will you solve this equation using trigonometric identities that you have memorized?
So we can take it as sine A minus sine B, and
Good.
then by moving it to the other side, and then we find the value of sine A minus sine
In
B.
a factor form, then you will be taking up the multipliers when it will become 0 and you will be counting the number of things inside it.
Yes.
But once you understand the graph, like you will understand it, the things work out very easily. It doesn't take that much time. Okay, people, clear?
Yes.
Great. So tell me if
So
you're done, I'll erase. Yeah.
you said the 2 points of intersection, they merge at the middle crest. So shouldn't we subtract 2 from the
That was
total?
counted, right? Done. Okay, this middle point is coming in the upper half as well as lower half. Yeah, it
So
was double counted.
between
Yeah, you are right. It's being double counted. You will remove it for once. It's a duplicate counting because this point of 20 pi, if you're going to count it as the upper half counting, okay.
So, but we're not counting it in the upper half because we count 0 for the upper half. So what we
Yeah, that's
count
what
is
I'm saying. You are counting 0, right? In that cycle of 0 to 2 pi, you can see you are counting this point. You're counting this point. So you are calling like 2 intersection point for this upper half cycle, 2 for this, 2 for this, 2 for this, again 2 for this. So this keeps happening 2, 2, 2, 2 for all these upper half cycles until we reach 20 pi, correct? So
yes, sir.
those 10 half cycles, they add their independent 2 intersections for each, 10 into 2, 20.
Yes, sir.
Then when I start from 20 pi towards 40 pi, so they are to be considered like this is the starting point of my lower half cycle, correct? So again independently 2. So this 20 pi was not counted. No, it was not counted in the upper half cycle.
Yes, sir. No, I wasn't talking about that. I was talking about at 10 pi, we count where the 2 points they merge into one.
Exactly
We
at
count
what point you're talking about?
at 10 pi and 30 pi, I think.
At 10
That-
pi. Let's see where we have our 10 pi. This is 18 pi, 11 pi, and this is our 10 pi, right?
yes, sorry, sir. I get it.
So is that clear, people? Great. So now we are getting a small hold on how periods are working, right?